A black screen, silence. You're waiting for a chat window to appear. It doesn't come. Instead, a notification blinks onto your screen. Supply chain bottleneck resolved. 3 contracts renegotiated. Approved? You didn't ask for this. You didn't open an app. The system saw the problem, cross-referenced your vendor history, drafted the mitigation strategy, and now asks only for your signature. This is not a demo. And once systems start working this way, there's no button to turn them back into tools. This is the moment the chat interface became a transitional fossil. Intelligence is no longer a destination you visit. It is an environmental layer baked into the operating system of the world. By the end of this documentary, you will see the infrastructure that is defining the next phase of AI, from self-healing code to sovereign AI clouds. The most powerful AI is the one you never see. Chapter 1: When AI stops asking. We are crossing a threshold, the end of generative AI. What comes next is Agentic AI, intelligence that doesn't create content but executes outcomes. In the current deployment cycle, a significant share of enterprise applications are embedding task-specific agents directly into their core. There will be no more prompts. The operational model is shifting. We're moving from human in the loop to human on the loop. You don't tell the AI what to do. The AI observes your workflow, anticipates the objective, and asks for sign-off. This is not about making AI smarter. It's about making it invisible. The global market for these autonomous systems is projected to surge toward $196.6 billion over the coming decade. This marks the structural shift from experimentation to production readiness. This is not speculation. This is infrastructure. Chapter 2: The Invisible Stack. Most software today speaks different languages. Your banking system doesn't connect with your finance tools or your customer systems. Humans bridge the gap. We copy data, translate formats, and carry information between silos. A new layer is now appearing between these systems. It's called agentic middleware. It doesn't wait for prompts. It infers intent from behavior and history. Here's how it works in practice. A supply chain bottleneck shows up in your operations software. The middleware identifies it, cross-references vendor contracts in your database, and drafts 3 mitigation strategies. It sends them to the CEO with a single question: approved? No one asked it to do this. It observed the pattern and executed the workflow. This is already happening in financial orchestration. Cloud teams are deploying agentic FinOps systems that autonomously manage costs and security across multiple clouds. The software is connecting itself, but there's a trade-off. Because the process is hidden, every action must generate a time-stamped logic chain. Humans need to review why a decision was made after the fact. The audit trail becomes the only proof the system is working correctly. In this phase, the code itself starts to change. Chapter 3: Code that fixes itself. Software has always been static. A developer writes it, deploys it, and waits for bugs to surface. In this transition, that model breaks. Agents don't just execute tasks, they redesign their own architecture. They monitor live deployments, identify inefficiencies, and refactor their own code in real time. This is called autonomous DevOps. The system uses continuous cognitive loops: perception, reasoning, action, reflection. It optimizes itself without human intervention. One implementation is called the Darwin-Gödel machine. It's an LLM agent that iteratively modifies its own source code to improve task performance. It discovers solutions human developers couldn't conceive, because it's testing thousands of variations faster than any team could. Another deployment is self-healing apps, software that detects bugs during live operation and applies patches instantly. Zero downtime. No waiting for the next release cycle. Here's the catch. Early adopters build systems that get exponentially smarter every day. Competitors using static software fall further behind. The performance gap becomes insurmountable. Software is fixing itself, but hardware is about to leave the screen entirely. Chapter 4: When AI leaves the screen. Until now, AI has lived inside screens. Now, it is entering the physical world. This is the deployment of physical AI, collaborative robots, cobots, and autonomous machines operating in uncontrolled environments. Today, 58% of companies report limited use of physical AI. Over the next deployment horizon, that figure is expected to rise toward 80%. The technology is moving from repetition to adaptation. Robots are no longer locked into single functions. In factories and hospitals, polyfunctional robots are appearing. Machines capable of switching tasks quickly, from assembly to elder care assistance. Autonomous logistics is expanding. Drones and delivery bots are entering public spaces like city streets and campuses. They're powered by mapping vision that no longer needs controlled environments. They navigate the real world. But this creates a gap. Companies aren't redesigning roles fast enough. Simply adding robots without re-architecting workflows creates friction, not productivity. The human side of the equation hasn't caught up. Robots are entering our physical space, but our data is retreating into private fortresses. Chapter 5. Who owns the intelligence? For the past 3 years, most AI has run through public APIs. You send data to OpenAI, Google, or Anthropic, and they send back a response. That model is now collapsing. Enterprises are building AI stacks inside their own security perimeters. This is the shift to private AI. It's driven by two forces: the risk of shadow AI and regulatory crackdowns. Companies need GPT-level reasoning without their proprietary data ever leaving their infrastructure. So they're building sovereign clouds. Nations and corporations are deploying AI infrastructure under their own laws and data residency rules. This ensures strategic independence. Enterprises are using private RAG layers. Vector databases act as long-term memory inside their own firewalls. The LLM is used only for reasoning, not for knowledge storage. The knowledge stays local. For most employees, this shift will feel invisible. But for companies, it's the moment AI stops being a rented service and becomes a core strategic asset. But building a private AI layer requires heavy upfront investment. Orchestration layers and query processing middleware that public APIs handle automatically must now be built in-house. The cost shifts from subscription to infrastructure. We've secured the data, but we still have to solve the problem of AI forgetting what it learns. Chapter 6. When AI stops forgetting. Current AI models fail at cognitive endurance. They can process long documents, but they lose the thread over extended tasks. If you're managing a financial case spanning weeks, the model forgets the original thesis. This is called context drift. A new architecture is now arriving. It's called test time training, or TTT. Instead of reading a document with a static model, the model updates its weights in real time. It compresses long context into memory during the inference phase. Research indicates the community is arriving at a basic solution to long context. Models are beginning to process 2 million tokens or more with constant latency. This enables long-horizon agents that plan and act over time. Financial or legal AI that can manage workflows spanning weeks without losing the thread of the investment thesis or case history. This is the difference between an assistant that helps in the moment and a system that can carry responsibility over time. It also enables hierarchical memory systems, an AI that distinguishes between immediate task facts and long-term organizational rules. This prevents memory leakage between projects. The system remembers what matters and forgets what doesn't. The limitation is this: training at test time is computationally intensive. It's 3.4 times slower for short context initially. The cost shifts from training to deployment. Once AI can remember everything, the economics flip, and soon it will be the one hiring the experts. Chapter 7. Who trains the machines? General crowdsourcing is fading. The demand is shifting towards smart data. Frontier models no longer need millions of generic labels. They need expert-level feedback to improve. This requires niche experts to train AI in specialized domains. But finding and vetting these experts takes time. AI agents are beginning to handle the recruitment. They scour global platforms, assemble teams of PhD-level experts, and complete the process in record time. Platforms like Micro-One use AI to recruit humans for AI training. The role of the human is evolving. We're moving from labeling to auditing and coaching AI, creating a new class of knowledge work. Automated expert assembly is already in deployment. AI agents find, vet, and hire niche experts for specialized model domains. The work pays well for those with expertise, but there's a downside. This isn't mass unemployment. It's a quiet re-ranking where some roles disappear entirely. Generalist labelers face mass displacement. AI automates routine annotation. An AI underclass is forming. The gap between expert-level contributors and displaced workers is widening. We're teaching AI to be experts, and soon they'll visualize data better than us. Chapter 8. When answers arrive instantly. For decades, business intelligence meant building dashboards. Analysts dragged and dropped fields, configured charts, and interpreted datasets manually. That era is ending. This is the arrival of Generative BI. You upload a CSV file. The AI instantly generates graphs, identifies anomalies, and drafts an executive summary. No human direction, no configuration. This shift towards zero manual BI is becoming dominant in enterprise analytics. It replaces the drag-and-drop era with autonomous insight generation. Executives ask plain English questions. Why did revenue drop yesterday? The system responds with visual, data-backed answers immediately. Conversational data analysis is becoming the default interface. And when answers arrive instantly, fewer people ask how those answers were derived. Self-building reports are already in deployment. The moment data is connected, the dashboard appears. Here's the issue. Without data literacy, users may trust AI-generated charts that are statistically flawed. Metric hallucination becomes a risk. The insights are instant, but the interpretation still requires human judgment. And the system that carries those insights is no longer bound to the ground. Chapter 9. When nothing is offline. All of this requires infrastructure. Autonomous agents, physical AI, and real-time analytics depend on ubiquitous connectivity. Satellite internet is moving from backup to everyday infrastructure. Satellite-to-phone networks are beginning to eliminate dead zones. This enables autonomous agents and devices to operate anywhere. No more coverage gaps. When connectivity becomes continuous, autonomy stops being optional and starts being expected. Early 6G pilots are beginning. These networks are 100 times faster than 5G. They enable real-time holograms and massive autonomous fleets. The latency is low enough for physical AI to operate in coordination across cities. Edge computing is expanding. Processing data directly on the device reduces latency for the rapidly growing population of connected IoT systems. Direct-to-cell satellite networks are moving from pilots into reality. Autonomous systems no longer depend on ground-based towers. Here's the cost. The rush to blanket the Earth with connectivity creates orbital congestion. Space debris risks increase and light pollution affects astronomy. The network is being built faster than the regulations governing it, and this brings us to the limits. Chapter 10. Where the system breaks. The technology is advancing, but the systems around it are not ready. The first limit is security. Training data poisoning is becoming the invisible threat of this phase. Attackers inject malicious data during the learning phase. They plant latent backdoors that activate only later. Because the corruption happens before deployment, it's harder to detect than prompt injection. The second limit is governance. As agents gain browser access and autonomy, indirect prompt injection becomes a vector. Malicious actors trick agents into unauthorized actions, like phishing or data exfiltration, without the user knowing. This is called the rogue agent risk, and it's unsolved. The third limit is technical. 42% of companies feel strategically ready for AI but operationally unprepared. Legacy systems cannot support the real-time demands of physical AI. The infrastructure gap is widening. The fourth limit is legal. State laws are struggling to define agentic AI and frontier models. This creates a fragmented compliance landscape. Risks are hard to trace across multiple agent decision nodes. Flawed reasoning remain a critical hurdle. Hallucination in decision-making is not solved. And when the decision is autonomous, the consequences are real. These are not hypothetical problems. They are active deployment barriers. Final chapter, the convergence moment. Now we arrive at the convergence, when multiple technologies combine and form stacks. These stacks replace workflows, not just tools. They operate as integrated systems. The first stack is the self-healing enterprise. It combines agents, self-evolving code, and private AI. A private AI layer hosts self-evolving agents that monitor enterprise software. When a bug is found, the agent autonomously refactors the code, tests it, and deploys the fix. All of this happens within the sovereign security perimeter. No data leaves the infrastructure. The second stack is the ubiquitous workforce. It combines physical AI, 6G pilots, and agentic middleware. Physical AI robots operate in city streets. They're coordinated by agentic middleware that negotiates traffic and delivery priority. The ecosystem is held together by ultra-low latency from emerging 6G networks and satellite meshes. Seamless operation without human tele-operation. These stacks are not theoretical. They are entering production now. The convergence matters more than any single tool because systems replace workflows. When workflows are replaced, the question shifts. It's no longer what AI can do, but what we understand. This phase of AI is not about new chatbots. It is about the industrialization of autonomy. The technology is moving behind the curtain into the operating system, onto the factory floor, and into the code itself. AI didn't just arrive, but receded into infrastructure. The invisible stack is not a metaphor. It is a description of deployment architecture. As we hand over the loops of control to software that can rewrite itself, and infrastructure we cannot see, we face a question. If the system works perfectly without us, do we still understand how it works? This is the cloned cat. Stay curious.